Hello there. In this video, I want to talk about linear graphs. I want to talk about the infamous y equals mx plus b. And I want to talk about how we can graph lines and properties that come from linear equations. Okay, and that's what this is called. This is called a linear equation. What kind of graph will it form? It will form a line. Line is the root word in the word linear. It will form a line. So this means a linear graph could look something like this, where it's sloping in an upward direction. We could be dealing with something where it is sloping in a downward direction. We could be dealing with something, sorry, it's incumbent upon me to put arrows at the end of my axes. It is proper. It could be a horizontal line. And it even could be a vertical line. Those are the main types of lines that could be drawn. In fact, those are the only types. But it is always a perfectly straight line. Now, the vertical lines we won't talk so much about. Those are not functions. And the fascination with algebra is around functions, or at least my fascination with algebra revolves around functions. Now, there's a couple things to observe when we're dealing with linear graphs, and that is that the rate of change is the same no matter how far apart your points are. So you will always get the same ratio, and that is called slope. And the slope is represented by this m in the parent form y equals mx plus b. That is a ratio meaning fraction, back to our vocabulary of rational numbers, is a ratio of the change in y over the change in x. So that would be our fraction. We would calculate the difference in y values, the difference in x values, and put them in a fraction that would look like this. This is sometimes referred to as rise over run. And rise is kind of a misleading term because it means we're always going up. But this first graph, I could label this point here and this point here, and I'm going up and then I'm going to the right. With downward sloping graphs, there's two ways to look at it. We could go up and to the left, or if I just choose two randomly other points, I could go down and to the right. So rise can be a little bit of a misleading term. Now, to play devil's advocate, if I had two different points on this upward sloping line, I would go down and to the left if I wanted to. But the idea being that we're looking for that change of x and change in y, and in these graphs, those, no matter how we calculated it, it should always come to the same answer for that specific line. Notice in a horizontal line, if I were to pick 2 points out on them, we're not going up or down at all, and we're just going to the left or to the right. So this would have a slope of 0. This can also be called a constant graph because this would just be represented as y equals a number. And then if we're looking at the vertical line, if I pick 2 points out at random, we're not going left or right, we're just going up or down. This would have no slope, or probably what's more proper to say, an undefined slope. And let's think about why. If we're not moving left or right, then our rise over run, well, we'd have a rise. We don't know what it is at this moment because we're picking arbitrary points on an arbitrary graph, but our run would effectively be 0. We're not moving left or right, and this gets back to the idea that you can't divide by 0. So this would be an undefined slope. Sometimes people say, though, that it has no slope, primarily though this can get confused with a slope of 0 because 0 represents nothing, and nothing means you don't have anything. So it seems equivalent to say a slope of 0 is no slope. So it's more proper to say undefined slope. And then we also need an additional point, and that additional point is the y-intercept. And that is, of course, the point that crosses the y-axis. Now, this graph has no y-intercept, the vertical line has no y-intercept. It does not intersect because it is parallel to the y-intercept. In fact, the only way it would have a y-intercept is if it was directly on top of the y-intercept, but then it would have infinitely many y-intercepts. And that y-intercept is represented by this letter B right here. This is our y-intercept. So this is a handy form to have at our disposal, primarily because it just tells us right off the bat, this is your y-intercept. Okay, so let's talk about some examples. Let's actually graph these equations because that's what we're here to do. So I've got this equation, y equals negative 2x plus 3. Okay, so I'll draw my axes, put the arrows at the end, because axes extend forever. Now, we always start with the y-intercept. Okay, again, that would be our 3 in this case. Okay, now it's a positive 3 because it's plus 3 in the equation. So that means from my origin as my official starting point, I'm going to count up 1, 2, 3 on my y-axis, and I'll plot a point. Now, in geometric terms, we have to think, how many points do I need to graph a line? And you need 2. You could do more. That's perfectly fine. And it helps with accuracy. But at the same time, we only need 2. So this is point 1. And you always start with the y-intercept when it's written in this form. The next is to do the slope. Okay, the slope is that coefficient of x. That's negative 2. But remember I mentioned how it's a ratio. We want a fraction. We want to be able to do some steps involving both going up or down and left or right. Well, if we think about what negative 2 is as a fraction, it's just a fraction over 1. And this is something you would want to get in the habit of doing every time you do a problem like this. Take the slope that is an integer and just put it over 1. So what this means is we have a rise, and I won't even write rise because, again, that can be a misleading term. We have a negative 2 as our rise, so this would be down 2, and that would be right 1. If it was a negative 1, it would be left 1. So I'm going to go ahead from my y-intercept. I'm going to count down 1, 2, and I'm going to count right 1, and I'm going to plot a point. Okay, so let me write it in a different color. That was 1, 2, and then right 1. And that would be our second point. And then at this point, all we need to do is draw it. Okay. Now, to be clear and concise and to be complete in how I teach this, I want to explain to you a slope of negative 2 could also be, we could say this is, we could move the negative to the denominator. When you have a negative fraction, the negative is interchangeable whether it's in the numerator or the denominator. So we could say that this is up 2 and left 1. And if we do that, we can see we count off 1, 2, and left 1, and we would get the same exact line. We'd get a point on that line. This is to give you options. Primarily, this misdirection can come in handy if you're working with a graph and you discover, you know, the graph extends forever, but we have a finite sheet of paper, and I'm about to go off that finite sheet of paper, so I need to go in the opposite direction, okay? But typically, I like to stick with this being to the right, the run being to the right, because then it makes things a little bit more easy. Okay, let's look at the second example. Let's go ahead and draw our axes. And I'll write it out again. We start with the y-intercept. That would be this 3 right here, but now it's a minus 3. Before it was a plus 3, now it's a minus 3, which means this y-intercept is negative. So when I count off, I'm starting from the origin. I'm counting down 1, 2, 3. And I'm plotting my point. Again, only need 2 points. And now my slope. I'll write my slope here. Let's go ahead and do it right in this region right here. Slope. Now, this time my slope is a fraction. That's great news. I don't have to remember take an integer and make it a fraction. Both numbers are positive because the fraction overall is positive. Okay? So this is up to and right 5. So I'm going to go up 1, 2. So I'll actually do this in red. 1, 2, and then go 1, 2, 3, 4, 5. So right there. Okay. Then I'll graph my line. That's acceptable. Ooh, that's not. I'm going to undo that. All right. So up to right 5. Now, if you like the misdirection that we had in the previous where I went up 2 and left 1 instead of down 2 and right 1, let's do that for this example. With positives, it can be a bit tricky because you see a positive fraction and you think positive over a positive. But we can also remember that this could be written as -2 over -5 because a negative divided by a negative equals a positive. And so in which case, if we wanted to go the other route, this would be down 2 and left 5. And so let's go ahead and check our work. 1, 2, and then 1, 2, 3, 4, 5. It looks to be more or less on the money for a hand-drawn graph, but we can see it would lead us to the same line. So again, my recommendation is always go to the right with your run and let the chips fall as they may for your rise being up or down. But again, sometimes we run out of room on that graph and people want to look at it and go, okay, how do I do this? You can change directions and go the other way. Some people don't like going off the graph, even though it's perfectly within your right to extend whatever graph is given to you. This is also why I like hand drawing my own graphs, because then there's no limit to what I can do. All right, let's look at one more form. Let's look at the graph of 3x minus 4y equals 24. Now, this is not y equals mx plus b. And while we're at it, I don't think I mentioned it. This is called slope intercept form. We just got to think about that name. Slope and intercept. It has the slope and it has the y-intercept. That's why it's called slope intercept, because we can look at those things and see them right off the bat. This is not slope intercept form. We don't have y equal to its or by itself on one side of the equation. We have a coefficient with it. This is what's called the standard form. Okay. Well, I mean, it's tempting to assume, okay, well, my slope is 3, right? That is the number that goes with the x, and 24 would be the y-intercept. And that's actually not true. We've got that coefficient of actually -4 with the y that's messing everything up. So that makes it so that the slope is not 3 and the y-intercept is not 24. I'm going to go ahead and show you how to do this in 2 distinct ways, and you can pick which one you like the best, and I'll explain to you which one I like the best. So the first is what's called using the intercepts. Using the x and y-intercept in particular. Now, you might be asking yourself, well, you said that we don't have the y-intercept, and that's true, but we know how to get to the y-intercept, and it's just as simple as thinking when a graph has a y-intercept, it's intersecting the y-axis. What is the x value when we're dealing with a y-intercept? And the answer is it's 0. We don't know what that y value is yet, but we know the x value is 0. It's always going to be the case because that's when our graph is at the y-axis. So I'll draw my axes. Actually, I'm not going to draw my axes yet. I'm going to undo that. Because there's going to be some calculations involved. I'm getting ahead of myself. So what can I do? That means I can take this equation and plug in 0 for x and solve for y. Now, this kind of goes back to when we solved simple equations. Now, you could plug whatever x value you want into this and solve for y. It's going to get you the same answer. Why do we pick 0? Because anything times 0 is 0, which means we can get rid of that. And if we even want to take it a step further and say, okay, well, it's 0, so I write out 0 minus 4y is equal to 24. Well, 0 minus 4y is just going to give you negative 4y. So we end up dropping it anyway. And then we will divide by negative 4. And our y-intercept will be negative 6. Okay, great. Let me write that up here. So this was negative 6. And let me go ahead and tidy this up really quickly so we can solve for our x-intercept. Okay, x-intercept. Well, we haven't really discussed x-intercept yet, but we can use the same thought process. X-intercept means it's intersecting the x-axis. So that means our y value will be 0 this time. So x, comma, 0. So we'll just repeat the same process, only this time we'll leave x and plug 0 in for y. Again, you can plug in whatever numbers you want into x and y and solve the simple equation. 0 is the easiest because now, once again, we can get rid of that. And again, even if you say, okay, it's 0, well, anything minus 0 is itself, so 3x equals 24. And so we just need to divide by 3. That's about as simple as it gets. That's a wonderful outcome. So I'm going to go ahead. Oh, let's go ahead and lessen that a little bit. There we go. And we get 8. All right. Let me go ahead and grab my eraser and get rid of this, and we'll get to graphing. All right. So now, what do we have here? Bully for us, we've got the x and y-intercept. Well, that means we have 2 points on the graph. So y-intercept of negative 6 means I count down from the origin 6 units. So 1, 2, 3, 4, 5, 6. Okay, great. X-intercept. That means we got to count right 8 units from the origin. So 1, 2, 3, 4, 5, 6, 7, 8. And we have our solution. Okay, great. That is my preferred way because it's easiest. We're plugging in 0, we're canceling it out, and then we're just doing one quick division and we're done. Well, really, 2 quick divisions. What's the other way? Well, this is sometimes preferred because it relates it back to slope-intercept form. We can convert this. It's the same as solving a simple equation, only this time we're not dealing strictly with numbers. We got to deal with variables. So what does that process look like? I got 3x minus 4y is equal to 24. And the goal is to isolate y. I don't want any coefficient next to it, and really that just means I need a coefficient of 1. And I want everything else to the other side. So I'm going to start by subtracting 3x. And I get negative 4y. Don't forget to carry down the minus as a negative now. And I'm going to write it as negative 3x plus 24. 3x and 24 are not like terms, so we can't subtract them. And then the last step is, so I can undo this multiplication of negative 4, I'm going to divide everything by negative 4. So this will cancel, and I'm left with y. That's my goal. I just got to do the rest of the calculations. Well, I get a negative 3 divided by a negative 4. That gives us just a positive 3/4. And I'll keep it written in fraction form because, again, we want that rise over run. And then a positive 24 divided by a negative 24 is a minus 6. And hey, look at that. Our y-intercept is negative 6. So now what we have is it written in slope-intercept form. So let me clear this away and we'll get to graph. Great. So we've got our y equals mx plus b form. We have our slope-intercept form. So we start with the y-intercept. Again, that's a minus 6. So we have to treat it as a negative 6. So down 1, 2, 3, 4, 5, 6. Plot a point. Same as before, so we're off to a good start. And then our slope, I'll write it out in this region right here. Slope is 3 over 4, and I'm going to write it below it. That would be up 3 and right 4. Okay, so let me write it in a different color. 1, 2, 3, and then over 1, 2, 3, 4. All right, great. Let's go ahead and finish our line off. All right. Now, really quickly, if we wanted to do that one more time, again, you need 2 points, but you could go 3. Let's go up 1, 2, 3, and we're at the x-axis. And if we go over 1, 2, 3, 4, look at that. We're at x equals 8 because we've gone right 8 times. We've gone up 6 times. So we're at the point 8, 0, which comes all the way back to our x-intercept. So again, it depends on what you prefer. I prefer the intercept method because it's just a few quick calculations, plot the points, and go. But you have to choose what's best for you. You have to take ownership over your education. All right, let's round off this video by talking about its properties. Specifically, let's talk about domain, range, x-intercept, and y-intercept. Now, the domain is, well, let's draw a general graph off to the side here. And I'll draw an increasing graph, but without loss of generality, we can apply the same thinking to a decreasing graph, okay? And if you don't believe me, you can go back to the beginning of the video and apply that to the graph we drew out at the beginning. We have 2 arrows. Whenever we see an arrow at the end of a curve, so long as we don't have any discontinuities in the middle, we're going to begin and end at infinity, or rather begin at negative infinity and end at positive infinity. And no matter how we draw it, no matter how we move this line around, that will always be our domain. The range, same thing. This arrow here is pointing down and to the left. Well, down means we start at negative infinity. And then this other arrow is pointing up for the purposes of our range. So it is also negative infinity to infinity. And that means our properties of a linear graph, domain and range, will always be all real numbers. Now, the x-intercept, how specifically we calculate that and how specifically we can create formulas or identities to help us with that process, I'm going to talk about in the next video. But at the same time, let's just discuss that because of the shape of the graph, it's only going to intersect the x-axis at one point. So I'll just note for now it's going to have one x-intercept. Okay. Y-intercept, well, that would be b, we already discussed it, it's b in y equals mx plus b. And more appropriately, we should probably write it as 0, comma b. Whatever that number is, you fill in the blank, just to remind us that it's a coordinate pair. All right. Now, really quickly, if we want to think about it, though, and this will give us a hint on how to solve for the x-intercept. But if I take the general form of standard form, that's ax plus by equals c. Remember, we solve for it by taking c and dividing by b. So our form is 0, comma c over b in our standard form ax plus by equals c. So that gives you a little bit, maybe you don't have to do all the calculations this time. Maybe all you do is look at, okay, I take that constant that's by itself, divide it by the coefficient of y, and I have my y-intercept. If you enjoyed this video, go ahead and give it a like and subscribe to the channel. If you have any additional ideas for videos in the future, please leave them in the comment section, and I will see you for the next video. Thanks for watching. All right. I think I'll finish linear equations and then call it a day. 5